What is grooving, everyone? Welcome back to Bo Math. How are y'all doing today? I'm not gonna lie, I'm a little bit bitter. I just recorded this whole episode, but I wasn't capturing the audio for it, so I just had a silent video, which is too bad, but hey, at least my explanation will probably be better this time around. So, in the previous videos, what we've been doing is shifting the number line, right? We've had a number line, adding and subtracting, and that's moving it back and forth. And I asked you to consider what would multiplying and dividing the whole number line look like. And I hope you took a look at that. If not, this is your last chance to do it, even though the title of the video might be a bit of a spoiler as to what it would look like. But give it a shot. Assuming you've done that, we're going to start by looking at perspectives on multiplication. So just as with the previous videos, go ahead and pause it and give me some explanations as to what multiplication is. See how many you can come up with. Alright, so one explanation is grouping things. One group is a group of two circles, let's say. And let's say I have three of those groups. How many circles do I have in total? Well, each group is two circles. So what we're going to get then is three groups of two circles. So that's 3 times 2. And that gives us 6 things. So one way to understand multiplication is taking groups. Alright, perfect. Next up is what I like to call glorified addition. What is 3 times 2? Well, we can think of that as doing 2 plus 2 plus 2. We're adding 2 to itself this amount of times, 3 times. And really this works well with the taking groups aspect of things because what we've done here is we have 3 groups of 2. So when we count all the circles that we have, we're doing 2 plus 2 plus 2. Ultimately, we're doing the same kind of thing. This is just a bit more of an abstracted look at things where multiplication is actually just a kind of a compact way of writing this addition here. Another way you can think about it is in terms of areas. Let's say I have a rectangle, and let's say this one is 3 centimeters tall, right? So this is 1 centimeter, 2 centimeters, 3 centimeters, and 2 centimeters wide, 1 centimeter, 2 centimeter. And what we can do is when we're finding the area of the rectangle, we just multiply this 3 by the 2. But what that actually is we're kind of extending these lines and we're getting all of these squares, and one square is kind of 1 unit of area. So in total we get 6 centimeters squared being the area of this because we've done 3 times 2, right? So that's another perspective on multiplication is its area. All right, and then the last one we can consider is multiplication on the number line. Not to the number line, we haven't done that yet, but hopefully you've looked at multiplication on the number line. So what would 3 times 2 look like? Well, it's kind of with this glorified addition perspective where we're taking 2 and we're adding it 3 times. So adding 2 once, adding 2 a second time, and adding 2 a third time. So we've added 2, we've done it 3 times, and so we get 6, right? 3 times 2 is 6. With this perspective, we have doing multiplication on the number line, which is just a visual representation of the glorified addition perspective. All right, so hopefully those perspectives are fairly familiar with you. If you have some other ones, feel free to let me know in the comments. I'd be interested to hear some ideas that you have for that. But now what we're going to move on to is looking at multiplying the entire number line. So in order to do this, let's go back and kind of review what is the number line. So we saw that the number line is like a nice spatial way of representing all of our numbers, right? And one thing we saw with that is that going from one tick to the other, the distance is always the same, right? We go from 0 to 1, that distance is 1. 1 to 2, that distance is 1 again. And we also saw with other number lines, for example, this one, if we labeled it in a different way, we could look at something like this, where the distance from one tick to another, in this case, is 0.1, or from another tick to another is 0.1. So regardless of the number line you draw, the distance from one tick to another is always the same. It's uniform. So this idea is going to be what the whole argument of multiplying the number line is going to hinge upon. It's very important. So what I'm going to do here is I'm going to draw a number line. And I've been using this ruler since probably about grade 6. It's a real handy thing to have. So I'm drawing a number line, and you may be wondering, okay, why are you not just putting another number line down as before? Well, remember, we're not shifting the number line this time. We're going to be doing something different. We're going to be stretching the number line as the title would imply. So what I'm going to do is I'm going to put these little pieces on the number line to basically kind of represent all of the ticks as before. We just kind of have to imagine that they're actually part of the line here. Okay, so I could include more, but because we're going to be moving these, I just want to focus on this region for now, but of course you can imagine there being a 4, 5, 6, and so on and so forth. So what I'm going to do is I want to multiply this number line by 2. All right, and so to do that, what we're going to do is we're going to take these distances and we're going to double the distance between two ticks. So this will stay the same in the sense that each tick will be the same distance from the other. But here we're going to be basically doubling the distance between all of these ticks. And ideally you would imagine kind of this all being stretched at once, but my fingers are sticking to these and I only have so much coordination. But yeah, just imagine the number line kind of getting spread open like this. So now the distance between two ticks is twice as it was before, right? And we see that everything now will line up with itself times 2. 1 lines up with 2, because 1 times 2 is 2. 2 lines up with 4. 2 times 2 is 4. 3 lines up with 6. 3 times 2 is 6, right? So this works just how we saw it with before, where the number, after we've transformed the number line, lines up with itself with whatever transformation we did to it. So in this case, multiplying it by 2, so 3 lines up with itself times 2, namely 6, right? Or negative 2, right? Negative 2 times 2 is negative 4. So by multiplying the number line, we're stretching it out, basically increasing these distances. Now the distances are still the same, right? The distance from two ticks to each other are the same on here, but they've doubled relative to what we had before, right? Before, they were this smaller distance, but now we've doubled that distance on all of the numbers. One thing to keep note of is that we kept 0 at the same spot. We say that we've fixed 0 here. So 0 never moved, but everything else moved. One reason 0 didn't move is, what's 0 times 2? Well, it's 0, right? You have basically 2 groups of 0. You still have nothing, right? So we keep 0 the same. And we can still kind of think about taking groups with this perspective as well, where to go from 0 to 2, it's 2 leaps, right? However, each of those leaps now is worth 2, right? Because we've doubled this distance here, right? So 1 leap here is actually worth 2. So because we've gone 2 leaps, we see that that's actually taking 2 groups of 2, or namely getting 2 times 2 or 4, right? So we can still kind of consider this in terms of taking groups. All right, with all this in mind, let's do an example. All right, so it says calculate the following by multiplying the number line. We have 1 times 3, 2 times 3, and negative 3 times 3. For all of these, we're multiplying by 3, so that means just one transformation of the number line, just stretching it once, should allow us to calculate all of these at once. So let's get a number line going, and let's draw a line here using my ruler from antiquity. All of these are being multiplied by 3, so we're going to want to multiply the number line by 3. And what that means is we're taking these distances that we had before, and we're stretching them out to be 3 times bigger. So again, try and imagine this kind of happening all at once, where the number line is being kind of pulled apart here to be, well, 3 times, to make these distances 3 times bigger than before. Okay, so now we just look at where everything lines up. 1 times 3. Well, 1 lines up with 3, so we get that 1 times 3 has to equal 3. 2 times 3. 2, that lines up with 6. So we get that 2 times 3 has to equal 6. Negative 3 times 3. Negative 3, that lines up with 9. So that lines up with negative 9. So negative 3 times 3, right? Negative 3 times 3 has to be negative 9. So just by increasing these distances by a factor of 3, keeping 0 fixed, we've effectively multiplied the entire number line by 3, and that's when we choose any number on the number line, we just get itself multiplied by 3. So this one I think is going to be the most interesting part of the video, and that's multiplying by 0. So we're going to multiply the number line by 0. So you may recall that multiplying any number by 0 is just 0, right? If I do 3 times 0, that's saying I have 3 groups of 0. Well, I still have no things, right? So we're going to see something very interesting happen when we consider it with this perspective. Okay, so when we multiplied the number line by 2, we doubled the distance between these ticks here, right? When we multiplied it by 3, we tripled that distance. But now we're going to be multiplying by 0. So what do you think that's going to do to the distances? Well, it's going to make the distances basically become 0. So if a distance between two things is 0, right, then that means they're actually at the same point, right? So we're going to fix 0. And if everything has a distance of 0 from each other, they all have to be on the same point, but 0 is fixed at 0. So that means everything is going to get collapsed down to this single point. So the whole number line gets smushed down to being right here. And everything then lines up with 0, which makes sense since anything times 0 equals 0, right? Negative 3 times 0 is 0, so it lines up with 0. Negative 2 times 0 is 0, so it lines up with 0. 0 times 0 is 0, it lines up with 0. Negative 1 times 0 is 0, lines up with 0, and so on and so forth, right? So everything, it gets just kind of, the whole number line gets crushed down to this single point of 0. And so I think this is a really kind of interesting visualization on what multiplying by 0 means. We're taking the whole number line and we're just compressing it down to be 0, right? Because these distances are becoming a distance of 0. All these ticks, if they're a distance from 0 from each other, are on the exact same spot, namely at 0. All right, and before we go, I'm going to consider one more example that kind of involves a real-life transformation. So we saw with the sliding of the number lines, that kind of was able to represent something moving in space, right? Or maybe it represents a change of perspective like we saw with the Mario example I did a couple videos ago. So now we're going to consider, basically, how would stretching the number line represent something in space? Well, what's something that you know that stretches a lot? A rubber band, right? So we're going to model the stretching of a rubber band using the stretching of a number line. Okay, so let's say our rubber band looks like it occupies kind of the regions from 0 to 2. And I want to stretch this rubber band to be 2 times as large. So I'm going to multiply this number line by 2. And that means these distances are going to be stretched out by a factor of 2, which will effectively stretch the number line by 2. And we will keep 0 fixed. So we won't move 0. Alright, so the whole number line got stretched out, but along with the number line, the rubber band also got stretched out. So you can kind of try and imagine the number line getting stretched out and the rubber band stretching along with it, but I only have so many fingers and so much agility. So we see here that the rubber band got stretched out. So it's still from 0 to 2 on the transformed number line, but relative to the number line that we didn't do anything to, and now goes from 0 to 4, which makes sense because 2 times 2 is 4, right? So we've doubled the region, which was of length 2, and now the region is of length 4 compared to what it was before. So the rubber band went from being of length 2, gets stretched out, to being of length 4, right? Compared to the old one. So this is just another way that we can kind of conceptualize or take a perspective on things kind of being stretched out in the real world. You can kind of imagine there being like an invisible number line there, it being multiplied by some amount, and then the object kind of just goes along for the ride with the number line. Alright, well, that's going to do it for me today. I hope you found this video interesting. I think this is probably the most interesting one I've done so far, but maybe your opinion differs on that. That's totally alright. My favorite example by far was the multiplying the number line by 0. I just think it's really cool that we kind of can visualize all of kind of this space here is being collapsed down into a single point. And in some ways that kind of shows that a 0 is a really powerful number. You multiply it and the entirety of all of your numbers gets just crushed down. Well, I hope you found that video interesting. Until next time, have a good one, stay groovy, and I'll see you in the next video.